Okay. Uh, Good day all.
Hello.
Hi, good day all, and good day, Captain Rohit. Thank you again for being with us, on fourth or perhaps the next follow-up time. Today, we are going to talk about a very interesting thing, which certainly has been a learning curve, not only for the airline industry, but also will, give us some food for thought as far as this particular incident, which will be talked about by Captain Rohit Kumar. He doesn't need any more introduction. We know I've already spoken about him that he not only being a legitimate pilot with a reputed airline, but also a trainer. And today we are going to talk about Airbus 330, where this particular incident took place, and it'll be all over to Captain Rohit, who will be narrating the whole thing and trying to educate us from the aviation industry, like how what actually happened, probably kind of insight, which we would certainly be grateful for to him to narrate the whole thing. Good morning and good day, Captain Rohit, sir. Thank you very much to come on our show. And how are you? How are the things at your end, sir?
Very good. Thank you. A very good morning to you, and thank you for having me on your show today. And
Thank you, sir.
today we are, as planned, we are going to discuss about an Airbus 330, which
Right, sir.
is a wide body airplane with two engines, so largish airplane, and
Right.
it carried out a feat, which is I think one of the longest uh, glide by a commercial airliner.
Longest
A
flight by
glide meaning, when you say
longest
glide
glide.
meaning,
Okay, okay,
there is no engine, as in
okay.
without engine power. It's gliding just because by its own aerodynamics, the wings and whatever the way the aircraft is designed and it's flying just by
Okay.
that. There's no engine power in that. So we're going to discuss about this situation. Of course, that should never have happened in the first place, but the outcome of this was very good. So what
Hmm.
we are going to discuss about in this session today is a bias that caused this, the reason for this that happened, extreme skills of the pilots to land this airplane safely with both the engines
Shut down.
inoperative, and we'll also look at certain errors that cause this, and we'll in the end we'll also talk a little bit about how the Swiss cheese effect came
Swiss
in
cheese
in this.
model.
Yes, the Swiss
Yes.
cheese model came in into effect in this particular incident. Yeah, we
Okay.
can. Is that okay? So
Yes, sir. Please go ahead.
this particular, we're not going to name the airline. We don't need to. We're just going. We are interested in the technicalities and
Yes,
the
yes,
learnings out of
yes.
it. So this
Definitely.
particular Airbus 330, which was from just supposed to fly from Toronto to I think Portugal,
Okay.
and they're all set, about 230 odd passengers, and nice takeoff. 4 hours into the flight, everything is fine, and it's a long flight. So as usual, it's planned every half an hour or 1 hour, depending on airline policy and the kind of flight. We do a fuel cross check,
Okay.
and the fuel cross check was all fine. Everything was fine. So there really was nothing for them to worry about or start thinking in that anything was about to go wrong. So mainly when we check a fuel calculation, what we do is how much have we burned till now, how much fuel do we have, and is everything fitting into place. So if I burned some X number of kgs from my total, I know remaining should be this much, and if that is there on board, I'm fine. So everything is fine with my fuel calculation, and I'm also concerned about am I burning more fuel or less fuel when I reach particular points. so that by the time I reach my destination, do I have enough fuel to reach the destination, as well as enough fuel to, in case I divert from the destination to my alternates, do I have enough fuel? So everything was fine in this case. So 4 hours into the flight, everything is good. All of a sudden, after some time, they see a fuel imbalance message comes up, which is quite weird for them.
Okay.
And before the fuel imbalance message, what they get is again a weird kind of an indication on the right engine. The right engine oil pressure is increasing and the oil temperature is decreasing. In a running engine, if in any running engine, a decrease of oil temperature does not happen
Okay.
unless the engine is shut. You take any engine, even in your in the ships, if the engine is running, the oil temperature has to increase, right?
Correct.
And the pressure has to be high enough
Basically,
in a
it's circulating into the system, so definitely gets heated up.
right. So there
Right.
is no reason for in a running engine for the oil temperature to drop down. So now see the bias is being built up here in the captain's mind and the crew's mind rather. It's something weird is happening in a running engine that should not happen. So now the first conclusion that they probably make is, oh, the computers are misbehaving. There's something wrong. This is not a normal indication. It should not come as per
Right.
my logic or anybody's logic, that if the engine is running, the oil temperature should not be dropping unless the engine is shut. It's not the case. The engine is running. So now the bias is being built up. So they probably had a discussion. No, this computer is showing some error. After a while, they get a fuel imbalance, which is showing that the left engine or the right engine has used, or there's less fuel in the right engine, the starboard, as compared to the port. Remember, now the first indication was wrong according to them. Now again, oh, I don't know what's wrong with the computers. It's giving us all these indications. Just now, half an hour back, we calculated the fuel. It was all fine.
Right.
Suddenly, it can't be that there is an imbalance.
Mm-hmm.
Now, the second bias is being built up. Okay. Now there is a checklist. If there is an imbalance, the checklist says you can balance it. How? By transferring fuel from one side to the other. I'll just show you that if I can have it.
Right. Right. Right.
Just a moment. Okay, just a second.
So you must be having an equalizing valve, a kind of
Yes,
equalizer,
absolutely. There's an
right?
equalizing valve which
Mm-hmm.
you can transfer fuel from one side to the other, and this is what it does. And so as once you have that, you'll see it's so easy to it'll be easy to understand. Okay,
Okay.
is this visible now?
Yes, crystal clear, Captain Rohit. Crystal clear.
Right. Thank you. So this, if you see my cursor at the center, is a transfer valve.
Yes. Okay.
Yeah. Okay.
Right.
So
Right.
what
Right.
they
Right.
what they end up doing is, see, initially your situation is the right wing or the starboard wing is losing fuel or less fuel. There is imbalance, and
Yes.
the port side there is more fuel. So the checklist says open this and allow the fuel from the left to come into the right. Okay.
Okay.
Now just remember this situation.
So, just one question. You have separate fuel pumps for port and starboard wings?
For both the engines, both the fuel, the tanks, you have separate pumps.
Fuel
Okay.
pumps. Any backup pump for redundancy or anything?
Well, you don't require backup pumps, because even if the pumps don't work, the fuel will be injected into the engine through gravity. So the way it is designed, the
Okay.
gravity effect would allow the fuel to flow into the engines. So that
Okay.
itself is the backup.
So just one question, just to, I'm also getting very
Yes, yes.
inquisitive about it. The equalizer valve line, it is going through that your cabin space, or of course it's out in your hull or inside the steel structure, but it is being led through the bottom part of your aircraft.
I think so. Yes, I'll have to check that
Because
exactly where.
only then the
Yes, yes. Of
equalizers will
course.
work.
Of course, there is some kind of plumbing that's passing through, but where
Correct.
exactly that plumbing is passing through, I'll have to check that in. I
ठीक
don't
है,
want to comment without
not an issue,
without that
not an
information.
issue, not an issue.
Right now, so
Right, sir.
they
Please go ahead.
start transferring the fuel. Now all the bias is being carried on. Now, at some point, they realize, oh, the captain realizes we are about 8,000 kgs less than what we should have been at this time. It still does not strike them there's something wrong. Okay.
Okay.
They realize now that they cannot make it to Portugal.
Okay.
And they say, okay, now this is trouble. And I'm not sure whether it's the computer, and mostly it's the computer which is giving me wrong indication. But I still don't have enough fuel to continue. So let's look for a diversion airport which is close by. Right.
Okay.
And in his mind, the captain's mind, he's not worried about the fuel still. He's worried more about a diversion, which will make him look like a fool when they land and they realize that nothing is wrong with it, with
Okay.
the airplane.
Understood.
It's just
Understood.
the computer. And this is the
Right.
thought that is going on in his mind. As he's thinking that, they lose the right engine due to
Okay.
fuel starvation.
Okay.
Okay. So when they lose the right engine, now suddenly he's back into the game. He's flying the airplane. So these airplanes, these commercial airplanes, if you're flying with both engines, they can go to up to 39,000, 41,000, depending on the airplane. But when you lose one engine, you can't fly at that altitude. You have to descend down. It will not be able to sustain that kind of altitudes. So they start
Okay.
their descent. They start their descent, ask for a diversion, and that is Azores Airport, and
Okay.
which is quite unique, which is like a tabletop, and there's water on both sides of the runway. And I'll show you that runway as well. It's very, very unique. It's like an island over there.
Okay.
So they start their diversion and they start their descent. They're passing through about 34,000, 31,000 or odd when they lose the other engine as well.
Oh, gosh.
Fuel starvation. The fuel from the left tanks as well has leaked out. Okay.
Okay.
Now they are without engines, with both the engines inoperative. There's no way they can run it. There's no fuel. So fuel starvation, and as a huge glider, tons and tons of weight, and imagine a glider like that. They
Yes.
have nothing else. At this point, they are about 60, 65 miles short of Azores Airport.
Okay.
And that's the glide. That's why it's called the longest glide by a commercial airplane.
You would say it's the longest glide of 65 some odd nautical miles before their
Not the
destination.
longest flight, longest glide
Glide, I
without
mean to say.
yeah, without engines.
Sorry. I
Yeah,
meant longest glide. I correct myself. A longest
yeah.
glide that is of 65 nautical miles prior to arrival at the
Yes.
destination.
Maybe somebody else has experimented it, but as far as known commercial history is concerned, I think this is one of the longest glide with passengers. Nobody's going to experiment that.
Certainly, it shivers. It still shiver
Imagine
in your bone, or you really can. Well, once you're there in that particular scenario, me
exactly.
me also being as a passenger, certainly I can imagine what sort of chaos must have been there in the
Absolutely.
cabin.
It is.
You know.
It is like you said, bone chilling because imagine that it's a quiet airplane at that point.
Hmm.
Your engines are not running. There's nothing else. It's quiet. You realize if you are the captain of that airplane or even a passenger sitting behind, you realize you're out with the elements over there. It's you and nature. That's all. There is no more additional power available. And at that point, if you are the crew, flying that airplane, you would require every bit of experience that you have gathered in your years of service, in your years of flying to complete that landing.
Yes, indeed. Indeed, Captain Rohit.
Because
Indeed.
if one option out is to land into water, survival rate is very, very poor
Okay.
because the airplane might disintegrate when it touches down because it's going to come down with a force. It might break
High
off.
speed, very high speed.
Yes, and
Yes.
so that would disintegrate the airplane. So survival rate is very, very low. Now the only option they have is this airport, which is about 60 miles away, and they try and
Okay.
make it, and they go for it. They start their descent. They start their descent. Of course, with these aircraft, when the engines are not running, there is no pressurization happening. May, imagine the panic that is going on in the cabin. There's no oxygen, so the oxygen mask drop. Remember the oxygen mask thing that
Yes, yes,
they
yes,
in the
yes, yes.
demonstration they tell you the
Emergency.
oxygen
Yes.
mask will drop.
Agreed.
The oxygen masks
Understood.
have come down. This is all happening in the cabin, right?
Okay.
Imagine what the cabin crew are doing to deal with the situation. What are the passengers going through at this point? Engines have shut. I'm sure you would one would realize oxygen masks have dropped. You're wearing their oxygen and probably praying, and I don't know what you're doing at that point. Now coming back to the cockpit, these two, captain and the first officer, are somehow flying the airplane, a dead airplane, dead engines, both of them. They reach a point, they're about 13 miles short of the runway, and I must show you this runway at this point because that is important for you to understand what a runway like this would do.
Hmm.
So they're about 13 miles short of this runway, and about, I think, same 13, 14,000 feet. Just give me a minute. So if they don't make it correctly, can you see this runway?
Uh, yes, now I can see Captain Rohit. Can you
Yeah.
make it a little bit more larger so,
Oh, I
me and
don't.
our
Oh,
audience can
wait.
see it clear?
Let me
Okay, that's fair
see.
enough. That's
Yeah,
good.
I can
We can
just
see.
this.
I can see
No, no,
Captain
no.
Rohit. I can see. Yeah, that's 100%. That's okay.
1 second. Oh,
Oh,
that's too
that's
much.
quite big.
Okay, this is better
Yeah,
now.
this is good. This is good. This is very good. Yes,
So
Captain
it's
Rohit.
sort of like a cliff.
Mm-hmm.
If you miss landing at the touchdown zone, you end up going on the other side into water.
Correct.
So you can't be too high or too fast. So you have to be
Okay.
at the correct speed to
Right.
land somewhere here, or else if you're
Mm-hmm.
too fast, you're going to end up on the other side of the runway and you fall off the cliff into the water.
Correct.
If you're too high, you'll touch down somewhere close to the end of the runway and go into the water.
Right.
Either
Right.
ways, you're in trouble,
Okay.
right? So they now this is the situation. They're very close to the runway and they're about still about 13,000 feet or altitude, and they're fast because you don't want to lose your speed too much too soon. Because if you lose your speed too soon, you might not reach the runway. If you lose your
Okay.
altitude too soon, you might not make it to the runway again, right? So both ways you have to conserve. This is energy, right? So the only energy you have is your speed and the altitude, which you can convert into, uh, a landing, a touchdown in the right zone. So these two energies you want to conserve as much as possible. So they bring it as close as possible. At some point, they realize this is now too fast, too high. So they make a 360-degree turn
Okay.
over there in front of the runway. Imagine the guts you require to do that, to push your nose away from the runway. It's not easy. You got to have guts to
I
do
can
that,
understand. Definitely. It certainly is.
right?
I can
You
understand what the captain must have been, undergoing what
exactly.
sort of turmoil.
So coming into the runway like that and making a turn away from the runway would require guts, although it's sensible behavior because that's what is required from your training. But it just still takes guts. A novice would just have pushed it straight ahead into the runway and gone off the other side of the runway. Now, this is the experience of this captain.
So this 360 turn, when what was the reason to take? I just want to know for
Yeah.
myself.
So in that 360 turn, what they end up doing is they're losing altitude, but they're not coming
Okay,
closer to the runway.
all
Getting my
right.
point?
Understood,
So they get
understood.
time to lose altitude, but at the same time
Right,
you're not
right.
coming too close to the runway,
Correct, correct.
right? And they do it successfully. By the time, so they manage to lose some altitude, bring their speed a little under control. They get a little bit of the landing gear down, they extend it, and flap 2 configuration. That's not important, but then they get a little bit of the flap extension, so to allow the speed to slow down. It's not fully landing configuration.
Okay,
And they come in over the threshold. They're still about 200 knots speed, which is for
okay.
even a 330, which is about at least 50 to 60 knots higher than the normal approach speed.
So normal approach speed is around 140, 150 something.
Yes, yes.
Okay,
So here
okay,
they are at
okay.
200 feet, 200 knots, which is
So,
very fast. You don't want to be too
okay,
fast. Like I said, you'll
correct, correct.
go off the other side of the runway. They've come down. They cross the threshold at about 200 knots, and the captain is keen on putting the airplane down on the runway. He forces the airplane down on the runway. Now the speed is too high. What happens when the speed is too high? The aircraft touches down and bounces high. Right?
Okay,
But the only advantage of that bounce was they managed to lose more of that energy, and the
okay.
aircraft comes down with a big thud and settles down. And they go on the brakes, both of them. I think they must have gone, pressed the brakes, applied the brakes as if they, and of course their life depended on that, on those brakes. So they both go on the brakes and stop the airplane. The airplane comes to a stop finally. Must have felt like the longest, landing for them. But then the airplane comes to a stop finally,
So this is
and they,
because she was flying at a speed around 60 odd knots more than the normal landing speed of 140, 150 knots.
correct, correct,
So
correct.
what you're saying is that when he had touched the runway, he must have applied the brakes full thrust, full force.
Full force brakes, and by the time they stopped, they burst about 8 tires.
Okay, must have been. I can understand. So
Eight
how
tires
many
was,
tires are there in this A330, Captain Rohit?
I think there. I think this must be a bogey. I'll, if it's a bogey, there'll be about eight. I think. We
16
don't.
odd,
I
let's
don't
say.
know.
That's okay. That's okay. Another question I'd like to ask you, like, when we are going there and we have to stop the ship, we give, reverse propulsion. We call it a stern moment.
There is
You have
there
the
is no
similar
engine.
thing?
We
No, no,
have, but there
no, no.
is no engine in this
No, under the normal
reverse.
circumstances, you give reverse thrust also?
Yes,
Okay, okay.
absolutely, absolutely.
So
That's
that
available.
means the reason I asked, I had put this question back that because he did not have the engines, so he had to rely all the way upon his brakes. And that was the reason probably he must have lost 8 tires, as what you were saying. So to
Right.
basically reduce the impact and reduce that or to stop that force when you land with such a high speed, you have nothing else, no reversing of your engines, but the brakes.
Absolutely. So it
That's
is just the
fantastic.
brakes.
Yeah, yeah, yeah. So I'm trying to speculate that what all things
Yeah,
must have been happening to keep up the pace with you as what you're narrating such a interesting and bone-chilling kind of story which you have just mentioned. So
true.
thereafter, what happened, Captain Rohit? So everything was okay.
Well, as far as this event is concerned, everything was okay. Everybody survived, and all was fine. Imagine coming out of an airplane where both the engines have failed. And I don't know whom you're going to thank, your stars, your God, or whomever, and you call everybody possible. I think it's that's why it's called the miracle of Azores.
Must
It was a
certainly it
miracle
is.
in
It
every
is the
sense.
way you have narrated and what actually happened based on the statements of fact. It certainly, definitely is a miracle. Definitely, I
It is.
concur to
It
that.
is a miracle. At least for the passengers, it was a miracle. And for the crew and everybody involved in that. It is a miracle. Uh, the survival was uh, caused or because of a miracle, we could say, but the reason for getting into the situation were certain biases and certain errors that was there, right? If you
Yeah,
remember, we
because
talked about.
in your case, you don't have any other way to gauge your fuel except from the computers. In our case, if my chief engineer is doubtful, he can always, go and take a sounding or check with his flow meter or other
Absolutely.
gauges and, and compare it. But in your case, there is nothing much can be done except for
Exactly.
relying upon the computer. So when we talk about the fuel leakage as which was there in the starboard engine, what was the cause, or is it normally happens, or is it something which is not normally heard of?
No, it's not normal. It should not happen. There are a lot of checks and balances that are put into place. Few flights back, this aircraft has had an engine change. The right engine, the starboard engine, had been changed.
Okay, okay,
Now, in this, when the engine change happened, there was some modifications that had also come, which the manufacturer had provided certain. They come up with a whole list of documents that have to be, followed. The process have to be followed when you do those maintenance actions. And because there was a change, of course, in the engine, and there was some design change in the hydraulic pump
okay.
of this engine, so it is probably a slightly a bigger size or something like that to make it as simple as possible. So now that required a different kind of resetting of the plumbing system of the hydraulics and everything. Now,
Okay,
but
okay,
in this particular maintenance action, the company did not follow the process that was required. Now,
okay.
slightly bigger fuel, the hydraulic pump was touching the fuel line.
So your hydraulic pipe was touching the fuel
The
line.
pump was touching the fuel line,
Okay,
right?
hydraulic pump.
Yeah, that's which is not important, but except that there's a mechanical structure that is hurting the
So that is getting
or
abrased.
abrading the fuel line
Abrasion is there between the two pipes or what you are,
between the
talking
pipe
about.
and the hydraulic pump, right?
Okay, okay.
So it probably must have gone through 5 or 6 flights, nothing happened, or it must have been a slow process of abrasion. In this particular flight, on that day, after 4 hours into the flight, that particular thing gave away finally, right?
The
That's when the
fuel
leak started.
pipeline gave way for the starboard engine.
Ruptured. The fuel
Ruptured.
pipeline
Yes.
ruptured. And this is
Right, right.
happening all inside the right engine before
Correct,
the
correct,
before the before where it is going to be injected into the
correct,
actual
correct.
fuel
Okay.
combustion.
Right,
Right.
right, right.
So see, the error was made when? Okay.
Error was made when they were, retrofitting the new engine on the old airframe,
Exactly.
right?
So
And probably the your procedures must have not been followed, or what I understand that there should have been some distance or a buffer between this
that's right.
hydraulic. Hi, Vijay, how are you?
Come
Between
say
the
hello.
hydraulic,
Yeah.
hello, Vijay.
Hi.
Hydraulic pump and hydraulic line and the fuel line. What I understand, there should have been some buffer or something so that they
Exactly.
do not come in the close vicinity.
Absolutely. So that's the first cheese, Swiss cheese, and the whole has gone through, right?
Yeah, so the Swiss
And
cheese model, how do we describe here, Captain Rohit? Just having a cup of tea. Cheers. Yeah.
I don't have a picture. Next time I'll get it. The Swiss cheese have got a lot of holes in them.
No, I know Swiss cheese model, Captain Rohit.
No,
What I'm
not not
saying is
not
that,
for you, just for the benefit of the
okay,
viewers,
no, we all do the similar thing that,
right?
when we talk about the risk assessment and how to curtail the risk factor, and then you do your thereafter assessment whether you should go or no go for this particular task or job or whatever the case may be. Swiss cheese is, of course, globally acknowledged, this
Understood
this
as well.
model.
Yeah. So the
Yes,
first the first error chain has dropped through that Swiss hole.
right,
Okay,
right,
that's when
right.
the maintenance happened. Now, It went on for 4, 5 flights, nothing happened. So the crew is not aware of it. They don't know anything about it. It's just pure luck. They happen to be on that flight, right?
So,
Now,
is there something pertaining to the commercial thing when we talk about the company? Because in our walk of life, and I'll be very straightforward, many owners or the management companies, they're penny wise, pound foolish. End of the day, the the blame game when it comes, the scapegoat is either captain and or the shipboard staff. Is it something similar to that in the airline
so
industry also?
anywhere there is a commercial consideration. You can't keep an airplane down for long. It
Exactly,
doesn't make you
exactly,
money,
exactly,
right? So
exactly.
there is pressure on the maintenance department to get an airplane flying as soon as possible. Whether they are forced to or not is a different question. We're not even aware of that. But there is pressure always on the maintenance department to get an airplane online as soon as possible. They are going to be questioned, why is the airplane down? Because the airplane on ground does not make money. Airplane that is flying will make money. So they would have pressure. I'm sure they would have had pressure to get the aircraft online as soon as possible. So that could have been the reason where the so-called jugaad was carried out. You know that word. So wherein they set that up whichever way they could manage, and then they just fit the pump, even though it was touching the fuel line a little bit. So that has happened.
You see, in our case also, I've encountered many a time fuel line bursting, leaking, or hydraulics failure or something or the other. But in our case, compared to your, we are still okay. We are at the most, if nothing happens, we are still afloat. And if I get strong drift, and I come to the waters within anchoring depth, I will anchor. So I'm still okay till I get some backup. But in your case, there
Correct.
is there is no U-turn.
There's no
There's no way
U-turn.
out, basically.
So
Yeah,
you
I
just
can
have to
understand.
glide the airplane down to the closest runway possible. In
Oh,
this
this is
case, especially.
certainly very, not only interesting, but at the same time very astonishing that how this, I think I saw your report, Captain Pichet. How did he manage to do this? He must have been, I can understand of course, what must have been happening and how he
He
would have
was,
been maneuvering
of
the
course,
aircraft.
they were recognized after the flight for their skills, but and also criticized for carrying out that action of the cross feed of the fuel. See, we got to understand both the extreme level of skills of the captain, also the error that was caused probably because of the bias or not understanding the situation at that point. It's easy again to sit here in this room to blame people. It's not like
Exactly.
that.
It's not
So
right.
yeah. So if they had not opened that cross feed, they probably would have ended up with only one engine failure, which is not such a big catastrophe because we are trained for that. We know how to fly an airplane with one engine. But the action of having the cross feed, they drained out all the fuel that was there in the whole airplane in the port side as well, and that caused the fuel starvation.
But somewhere down the line, I heard you saying that, because there was a problem with the starboard engine, and that's the reason when the captain went through the checklist and
Correct.
the thing was to open the cross feed or the crossover valve between port and starboard
Yes,
wings. So as far as the captain was concerned, he did the things,
absolutely,
correctly as far as
absolutely.
the checklist is concerned.
For him, it is a no-brainer, to because if you the analysis later on told what was happening was there was fuel flowing through the when there was fuel leak, it was flowing through that area where that's why it is cooling down the end the the oil pumps. It
Hmm.
it's supposed to flow through that, and it's flowing through that, and that's what dropped the fuel. I mean the oil temperature, because the fuel was flowing through that, the leaking fuel was flowing through that dropped the temperature of the oil.
Captain
That
Rohit,
which
this certainly, sorry, go ahead, sir. Go ahead, sir.
Yeah, so that was the indication which was contrary to any understanding the captain would have, right?
Captain Rohit, for the benefit of our viewers, can you please show the same diagram or the figure where you have the wings and where the fuel is getting injected into the
Yes, I will.
starboard or the port engine? So there you'll be able to explain that where approximately the proximity of leakage was, where the whole fuel from the starboard wing got drained out.
Yeah, give me a minute. I'll just bring that thing again. So here it is. It should show now. Mhm. Here.
Can you enlarge it a little bit more, Captain Rohit, so you know the people can see clearly? Yes, sir.
Is this visible now?
Maybe a little bit more if possible,
Oh, it just.
because the fuel inlet pipeline is
I
though
think
it can
this
be
is.
seen. Yeah,
Yeah.
that's okay.
Yeah.
So
So
yes,
can you can you see my cursor?
I can see, sir. I can
Okay.
see.
So the leak is somewhere inside the right engine, the starboard engine.
Okay, yes. So
And
that's where the fuel
somewhere,
injection is taking place into the starboard
yes,
engine.
somewhere here, the
Mm-hmm.
the hydraulic pump has abraded one of the fuel lines, and the leakage is inside this. Okay.
And your hydraulic piping goes through it because of the flappers, what you have for, your aerodynamics, what I see, because once you're
Yeah.
uh,
So these
on the window
you
seat.
you cannot move controls and surfaces without hydraulics, like any big
Correct. Well,
ships.
yes,
So,
definitely.
so the hydraulics are an important part of big machines, right? Even in a
Yes, yes,
ship or an airplane
yes,
or
yes,
anywhere,
yes,
right?
yes.
So now the fuel is being leaked here in this engine. What
Mhm.
worst case scenario, if they had not opened this cross feed,
Equalizer, yes.
the equalizer, what would have happened is the fuel leaking from the engine here, it would have used up all the fuel from the starboard, and you would have had a situation where the engine has failed or the starboard engine has failed. But this is shut, the fuel is available here on the port side, and the port engine is running. So you would have had a situation where it's your engine, one engine has failed.
Right, right, right.
But because of the bias that was created in their minds, they opened this cross feed and allowed the fuel from the port side to come in into the right engine and leak out through the right engine as well.
Very crystal clear, very, very well understood, Captain Rohit, and very, very well explained by you, sir.
So
Now, I have
this,
one question, Captain Rohit. What are the lessons learned after this particular incident to avoid any kind of future mishap, or what all the procedures have been amended and put into place to not to have a repetition of this kind of incident, basically?
so now the checklist is very specific about this, wherein it says anytime there is an imbalance, you don't start balancing fuel. First, make sure there is no leak.
Okay.
And if you have an iota of doubt, if there is that of any fuel leak, please do not switch on the crossfeed
Yeah.
because you're
But
going to lose all.
you are basically relying upon the computer and the sensors, right? So you cannot see that physically unless you can see some streak flying out of the starboard wing or something, which probably if it is noticeable. So what all additional provisions have been given to you?
So the additional provisions, they haven't given anything. They don't need to because it relies on our ability to manage. How? When you're going from place A to B, you have a certain fuel consumption rate. You know your engines will consume fuel at a certain rate. So 1 hour into the flight, I should know my engines have have burned so much fuel. I reduce that from what is
Okay.
available or add that to what is available. I should have what I started with. So that's a calculation that has to be, that's an ongoing calculation all the way. So
Okay,
that's
I
a very,
understand this is with your flow meter and the rating of the engine, that per hour, what's your consumption subject to your
absolutely.
speed.
Brilliant.
So yes,
Yes.
speed chart and your flow meter, flow rate and the consumption. So
Correct. Correct.
you
Correct.
once you do that, or it means this should be coming to you online, so you can approximately evaluate that. Okay, everything is okay. But if there is a drastic change
Exactly.
with respect to the rating of the engine, your speed and the flow meter reading, what you must be getting, so I can understand now. I can understand, sir.
So once I know that there is a leak, then I start wondering where. Then there are processes and procedures to find out at least approximately where exactly could the leak be from, and accordingly we isolate those areas. It's not 100% foolproof. We try and isolate. We try and identify which area it's. Is it from the engine? Is it from the in the fuel lines, or where exactly on the left or the right, starboard or the port? We try to figure out that and then isolate that area. That is what we do now.
But one question, I'm sorry, I'm getting a lot of questions
Please,
because this
yes,
is
yes,
certainly
please.
very interesting thing what you've brought it to me and to our viewers, Captain Rohit. Uh, the similar thing what we talked about, if you say the no machinery system has been changed, be it flow meter, okay, piping which was rubbing, okay, that certainly was a cause. But uh, in captain's mind at that point in time, were the similar calculations not going on before he opened the equalizer valve?
So yeah, so in his mind, we just for him it is like, oh, we just checked it half an hour back and everything was fine. You know what I mean?
Hmm.
They checked. So 4 hours into the flight, everything was fine.
Is it not online, or is it you have to put the menu or the sensors on to recalibrate your fuel?
No, the sensors are already there, so that recalibration cannot do on while flying. Of course, we know there are various different sensors at different places, but there is no recalibration done at that point. For him, that I told you, the two things that must have set him apart in his thought process was one, this right engine temperature dropping, the oil temperature dropping, and the fuel check that they had carried about half an hour back, where everything was fine.
So what he could have thought about it, the drop in the temperature, the fuel temperature.
So, according to him and anybody else also, in a running engine, the fuel temperature should never drop. If
Exactly.
in your car, I mean, not the fuel
Yes,
temperature,
yes.
the oil temperature. In your
Oil
car,
temperatures. Yeah.
if the oil temperature drops, I mean, in a running car, the oil temperature would never drop unless you
Never
shut down
drop
the
in
engine
any
and
machinery,
then
in any machinery.
any machinery, right? So that's now for him, it's obvious. Oh, it's showing me wrong indication. Either the
If you
engine
say
should
if you
see.
say oil temperature, so then I'm thinking it's a hydraulic oil temperature.
Not hydraulic oil temperature. There is oil inside the engine to run the, not the hydraulics.
Yeah, see, one is fuel, one is oil, one is hydraulics, what you use, one is fuel, which is there in the wing. So it's the uh, fuel oil temperature which was dropping. Correct me if I'm wrong. What I'm understanding.
The what was happening is wherever the fuel pump is or wherever it was measuring the oil of the engine, the fuel that was leaking, right? It was flowing through that. It's cold fuel.
Obviously, the temperature will drop.
That is
Temperature will
dropping
drop.
the temperature. And the
Yes,
indicator is just showing you a drop in the oil temperature.
and the pressure was high.
The pressure was high, so as because the engine was running. So now for the captain, that's contrary indication, which should never happen. So he's very clear. Oh, the computer is misbehaving, you know.
You see,
And
the
then
pressure. Yes,
yeah,
the pressure will automatically become high because when your pump is working towards something injecting, and if
exactly,
there's a leakage or something, now the pump is sucking the oil and it is giving more pressure, maybe a
correct.
kilogram per centimeter square or psi or a kilopascal, whatever you calibrate with. So that is of course understandable.
So he probably must have started with the thought that the computers are misbehaving. I'm getting wrong indication. Secondly, backed up by his calculation half an hour previously, which was also showing all correct. It's only when the engine failed, till then, even when they lost 8,000 kgs, or they were less than by 8,000 kgs, he was still not sure whether he should actually divert or not. Because in his mind, he was thinking, when I land there and nothing is wrong, the company is going to say, oh, what's wrong with you? You diverted a perfectly fine airplane.
Yes, yes, yes. I can understand the safety and the commercial constraint of the
Exactly,
captain, and at the
exactly.
same time, being skeptical not to make fool out of him, as what you said, when everything is okay and you have landed into a different
Diverted an airplane
destination.
instead of going to destination, you diverted an airplane and landed somewhere else. People are going to question your, sanity.
Exactly, and it incurs additional costs for the airline as well.
Exactly, exactly. So till now, in his mind, the gravity of the situation has not clicked till that point. Till they
Yes,
lose
yes, yes.
both the engines, that's when it really strikes that, oh, all the fuel is lost, and the engines have failed because of fuel starvation rather than any mechanical failure.
Yes, and could there have been any chance? I'm trying to ask you for my own knowledge. Could there have been any chances where the engine also could have caught fire?
No, if there's no fuel, there is no chance of engine fire. The
Then what are
only
the main reasons for the
catastrophe that could have
engine catching
happened.
fire?
Uh, Sorry, say again the question.
I said, what are the main reasons or causes for aircraft engine, catching fire or getting, ablaze?
Well, you would require fuel. In a fuel-starved aircraft, there is no question of fire. That would not happen. And biggest reason for airplane fires is the fuel leak. I mean, when they crash, the spreading of the fuel and probably some kind of spark or fire that has happened, and that catches fire. So if there is no fuel, the only uh, damage that could happen in this case is breaking of the airplane. There is no reason for it to catch fire because there is no fuel. If they had landed in water, the aircraft would have disintegrated. If they landed somewhere on land, that aircraft would have disintegrated. So survival rate is very, very low.
I'll share with you one very small thing. Probably we can talk about next lecture, next session. I was passing through in English Channel coming from North Sea. By the way, North Sea, there was a fiasco just a day ago. Two ships collided and they were ablaze. I'm still waiting to get the whole thing. Anyhow, I was coming from North Sea, passing through English Channel, and it was a big ship, deep draft vessel, and we had a scavenge fire. So on that ship, there were 6 units, means six pistons there. So what happened? The scavenge fire took place, and the thing is that I was in a critical passage where I cannot divert. The name of the place is Dover Strait. It's a bottleneck when you're passing from English Channel towards North Sea and other parts,
Mhm.
Rotterdam, Amsterdam, all these ports. So this Dover Straits is a very bottleneck area. So unfortunately, it happened with me in the Dover Straits, and I was taking a deep draft channel where it was much more restricted as compared to the other channel, the seaways. And suddenly I saw the drop in speed. We were doing around 12 to 13 knots, and suddenly I found the speed has come down to 5 or 6 knots, and the chief engineer was pretty good, and he called me up and said, "Captain, can we stop?" I said, "No, I cannot stop. If I stop, I will run aground." Now, the VTS, vessel traffic, VTMS, vessel traffic monitoring system, they are always monitoring you. So
Mhm.
the VTS called me up on the VHF saying, "Captain, is everything okay?" So I said, "Give me some time. Let me find out." And then the chief engineer told me, "Captain, this is it. I've got two of my units on the scavenge space fire." So I said, "Now what do we do?" He said, "I'll cut off the two units. So we'll be running on 4 units."
Hmm.
So what they have to do, they have to, do the smothering of fire. Sand is there, plus steam injection is there to smother the fire and cut off the fuel injection into those pistons. But it takes some time. But I was lucky that the chief engineer was good and he did timely. I barely came down to 3 knots or something, but it takes time to build up the speed in a ship and takes time to reduce, like same thing in your.
Mhm.
We don't have brakes. We only have
Correct.
anchors, no brakes. So then he had cut off the those 2 units and the fuel supply and steam smothering to extinguish the fire at that point in time. And he gave me 4 units, 4 pistons, and we were navigating with that. And then accordingly, I liaised with the Dover Strait Coast Guard, and thereafter, I had my next port of call was through Suez Canal, and I was barely making 6 knots, but still I could hold my head. So we have encountered these kind of situations, but yes, if
Mhm.
this thing happening in a critical passage where you have nowhere to go because you
Correct.
cannot anchor because it's a running lane, there's a traffic behind,
Correct.
traffic ahead,
True.
and even though if you might be in the anchoring depth, you have reefs and rocks and wrecks under you or in your vicinity, so there is no way out. So that was quite challenging situation for
Challenging.
me at that point in time. But
Correct.
yes, learning from your this incident report, definitely it is certainly an eye opener. And what can I say? Only have a very high regards for the captain, Captain Pishe, the way he did,
Yes,
because
absolutely.
there is no end to go for a fault finding mission. Anybody can find a fault in a
Yes.
perfect
You
situation
can
as well.
sit in an air-conditioned room and find faults, but we also have to understand the human brain, the way it is functioning.
Correct. The
See,
human
the error
factor.
has happened days before.
Yes, yes, yes,
He's not responsible for that error, but
yes.
he's responsible for stopping that error.
Definitely.
Getting
And
my point?
I
Now,
understand basically here how to come on top of the situation, how to curtail or the damage. The main thing is that irrespective of whatever happened, irrespective of the equalizer valve was open or whether it should have been done or not, there was no casualty, and he glided 65
that
nautical miles
that's the
off the
brilliance of this.
destination.
Yes, so there was a huge amount of skill involved and probably luck as well. So
Yes,
we also have to think about a lot of times when we talk about decision making, you know, maybe the process was wrong, but you got a good outcome. And
yes,
you are thinking, let's say, for example, I'm just going to put this into reference for a regular person. You probably invested in a poor company, in a bad company,
hmm,
and the market was good, everything was good, and you made a profit out of that. And
correct.
you go about saying, I'm a great investor. You know what I mean?
you may have
The
your
process
you
was
may have
wrong.
a feather in your cap in that way,
Exactly.
but
So the
yeah,
process
okay,
was wrong. The outcome was
exactly,
the way you wanted it. So you're saying that's fine. But
yeah,
can
yeah,
you repeat that thing again? Probably not. So that is why these learnings have to be understood by us. And that is why it is important for us to know this. Right? So this
definitely,
human
definitely.
biases and their ability to make decisions, there are a lot of things involved. That's the understanding or that we have got to have, so that we make repeatable processes which will give us consistent positive results, rather than only depending on luck to to come out of those situations. See, the
I
idea
understand.
behind these discussions, I think, should be to also for regular people to know that their decisions should be in a way that it is repeatable and they clearly understand what is going through, and so that they can get a positive result out of that.
Definitely, Captain Rohit, sir. This is fantastic. Very good session. I know it has been long enough, but then it is worth it to basically
Thank
come
you.
out with all the modalities and the way you have narrated, you have described, you have explained to us as commendable, Captain Rohit. Commendable.
So it's interesting, it's fun talking to you like this, and
Certainly,
since
sir.
your knowledge
Certainly, we will
is
definitely.
all
No,
is
we
amazing.
share the knowledge, and that's it. Yeah, matlab,
Yes.
this was something was a very great learning for me that. when you put yourself in the Captain Fisher's shoes, I can understand what the poor chap must have been undergoing at that point in time.
Absolutely, absolutely.
Thank you, Captain Rohit, sir. Thank
Thank
you
you.
very much. Good day.
Lovely.
Thanks for your time, and God bless. We'll certainly
Really
meet
good time.
again,
Thank
have
you.
another rendezvous. Good day.
Thank you.
Thank you, sir. Thank you.
Bye. See you. Goodbye.
Yes, sir. Goodbye.